Hi all. Today we are going to discuss about Unit 5. So in the Unit 5, all the topics are about measurements, like microwave measurements. So that measuring instruments, some measuring instruments are available here. So VSWR meter, power meter, and spectrum analyzer and network analyzer. So these are all the topics we will discuss in upcoming slides. And measurement of impedance, how the frequency, power, VSWR, Q factor, and dielectric constant value, attenuation value, scattering coefficients, and S parameters, how all these parameters values are measured in the microwave region. So it is all it will be discussed in the upcoming slides. So these are all about Unit 5. So, at low frequency, it is convenient to measure voltage, current, and frequency and use them to calculate the power. However, at microwave frequencies, the amplitude of the voltage and current on a transmission line are function of distance and are not easily measurable. So, hence at microwave frequency, it is more desirable and simpler to measure power directly. Therefore, it is necessary to measure power instead of voltage and current. So, the microwave parameters namely are S parameters, power, frequency and wavelength, phase shift, voltage standing wave ratio, that means VSWR, and noise figure, Q factor and attenuation. So what is measuring instrument? What is that? So a test and measurement system consists of one or more measuring instruments and one device under test, which is DUT. So the microwave parameters are measured by using the following instruments. That are VSWR meter, power meter, spectrum analyzer and network analyzer. So these are all the instruments which are used to measure the microwave parameters. Okay, so the what is initially we will discuss about what is voltage standing wave ratio and standing wave ratio. So the standing wave ratio is a mathematical expression of the non-uniformity of an electromagnetic field on a transmission line such as coaxial cable. Usually, this SWR is defined as the ratio of the maximum radio frequency voltage to the minimum RF voltage along the line. So, in radio engineering and telecommunications, standing wave ratio is a measure of impedance matching of loads to the characteristic impedance of a transmission line or waveguide. So, impedance mismatches results in standing waves along the transmission line, and SWR is defined as the ratio of the partial standing waves amplitude at an antitode maximum to the amplitude at So the principle and operation and application of VSWR meters are widely used to measure VSWR is defined as the ratio between the maximum voltage to minimum voltage, which means VSWR equal to Vmax divided by Vminimum and 1 plus root of power reflected divided by power forwarded and divided by 1 minus root of power reflected divided by power forwarded. Also, it is noticed that 1 less than or equal to VSWR less than or equal to infinite. So, if VSWR value is 1 for a perfectly matched network, if it is infinite for short and open circuits and mismatched circuits. So, it is a measure of how well the components of the RF network are matched in impedance. Standing waves occur when impedances are not identical, signal loss during transmission, poor reception and larger the impedance mismatch. So the construction of VSWR meter. So the typical VSWR meter is a high gain, low noise amplifier. It is tuned to the modulating frequency of the microwave signal 1 kHz. The display panel of the meter consists of 3 scales: normal scale, expanded scale and dB scale. In the normal scale, if the reading of VSWR meter is between 1 and 4, then the top normal SWR scale can be used. If the VSWR reading is between 3 and 10, the lower SWR scale is used. Next one is expanded scale. If the VSWR is smaller than 1.3, a more accurate reading can be taken by selecting the expanded SWR scale. It's graduated from 1 to 1.3. Then expanded dB scale, it is a third scale at the bottom, is graduated from in dB. decibels. To measure VSWR, the meter needle is initially adjusted to 1 after placing the probe in V maximum position within the guide. So the gain control panel is used for making this adjustment. For any input voltage, the amplifier output voltage is measured directly in terms of VSWR. The input of the VSWR meter is the detected output voltage of the tuned detector that is fed by a coaxial cable. And the principle of operation. So it is used to determine the amount of radio frequency that is being reflected back to the transmitter or source compared to the amount that is being sent out during transmission. If the ratio is high, the source will surely damage. So the maximum standard rating for a VSWR meter where a transmission can withstand is 1.5:1. So the ideal rating is 1:1 and the power reaches the destination and without reflection. So the types of SWR meters are directional SWR meter and SWR bridge circuit. So first one is directional SWR meter. It is generally used to measure the magnitude of the transmitted and reflected waves by sensing each one separately with the help of directional couplers. Here the transmitter and antenna are connected through an internal transmission line. The line is electromagnetically coupled with the two directional couplers. So the directional couplers are then connected to the resistors at one end and a diode rectifies at the other end. The resistors help in matching the characteristic impedance of the sensing lines. So the diode helps in converting the magnitude of the forward and reverse waves to DC voltages, will then be smoothened with the help of capacitors. And next one is SWR bridge circuit. A typical impedance bridge is built for determining the SWR impedance. The test impedance is increased until the bridge circuit is balanced. The test impedance will be equal to the reference impedance. Thus, with the help of the bridge circuit, we can know whether SWR is present or not. So, what is the problem with VSWR meters? VSWR meter cannot measure reactance and resistance. Instead measures the impedance. So, reading to be accurate, it must be matched on to the line impedance. So, any transmission line will have a certain loss. When this loss occurs, the reflected signal will be attenuated when it travels back along the line. Thus, for the SWR meter to be efficient, it must be connected very near to the antenna and further away from the load. So, the value of SWR will be more when it is nearer to the load. So, internal diodes of an SWR meters may generate harmonics while transmitting and produce intermodulation products during reception. And the applications of VSWR meter. So it is used absolutely in laboratories and live telecast systems, rail guides, flanks and tabs, telecommunication tracks and microwave based medical applications.